Good morning, everybody. Yesterday's video did not record right, so we're trying again today. We're going to do notes, so you can pause and get your notebook out and get ready to take notes. When you're ready, you can unpause. The title of these notes is Scientific Notation. So we're going to take a look. We've been talking about very big numbers. We're going to use 2 million as an example. So standard notation means write the number. As a number. I was saying write the number out, but that I thought was maybe not specific enough. So standard notation for 2 million looks like this. We have our 2 in our millions place, then we have our thousands places, then we have our ones places. And that is 2 million in standard notation. Okay, so scientific notation is write the number as a number times the power of 10. So, and this is not new to you, we've been practicing this. So 2 million in scientific notation, you can either remember that million is 10 to the 6, or you can count zeros, 1, 2, 3, 4, 5, 6, 6 zeros. So this is going to be 2 times 10 to the 6. And that's 2 mil in scientific notation. Okay, I'm going to erase this, so if you want to pause, you can. So the thing that we have not been talking about yet that is new is that scientific notation has rules about how you can do it. So I'm going to write it in algebra first. I'm going to say n times 10 to the p, where 1 is less than or equal to n is less than 10. Okay, and what this means, 1 is less than or equal to n is less than 10. What this means, that's the short math way of saying n is between 1 and 10, including 1. See the equals? That's including 1, not including 10. See how there's no equals there? Okay, so that's the algebra way to say it. Another way to say it, non-algebra, might be, oh, and p is the power of 10. Where we have a number, whoops, a number times 10 to a power, and this number has to be between 1 and 10. Including 1. not including 10. Okay, so again, I'm going to erase. So in class this week, we saw the number 60 million. You could write as 60 times 10 to the 6 or 6 times 10 to the 7. This one's not scientific notation. Because the 60 is bigger than 10. Okay, so another example, we had the 17 trillion, or maybe it was million, I forget. 1.7 times 10 to the 13 is scientific notation. Because this number, 1.7, is between 1 and 10. Okay, so 17 times 10 to the 12, not scientific notation. I just said side note. Okay, because the 17 is too big. This porridge is too hot. Sorry, I don't know where that came from. All right, and 0.17 times 10 to the 14 is also, or 19, is also not scientific notation because the 0.17 is too small. 17 is bigger than 10, 0.17 is smaller than 1. This porridge is too cold. Okay, so, oops, I forgot to tell you that I was erasing. Sorry. Converting numbers into scientific notation. I'm abbreviating scientific notation as sci note because I'm tired of writing it. Step 1. Place the decimal. So that your number, so that your number is between 1 and 10. So for example, if we had 37, 500, 0, 0, 0, 0. Okay, we want our number between 1 and 10, so we're going to place that decimal, let me switch to red, between the 3 and the 7, because then we have 3.75, and that gives us a number between 1 and 10. So it doesn't really matter where the commas are. You're trying to place the decimal so that you have one digit in the units place. This units place is always going to be filled. And the tens place is not going to be filled. So you want a number in the units place and then a decimal. Okay. Step 2. Count how many places you moved the decimal. Okay, now that we have numbers other than 0 in here, digits other than 0, it's not how many zeros there are, it's how many places you moved the decimal. Okay, so in this case we moved the decimal. Why is it not writing? Am I off the edge there? We moved the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you can also count if you'd like by threes. You can say 3. Try that again. You can say 3, 6, 9, 10. Okay, so count how many places you move the decimal. That is your power of 10. So I forget what it was, 3, 6, 9, 10. So this is 3.75 times 10 to the 10. Okay, I'm going to erase this. Numbers greater than 1. Have a positive power of 10. Numbers less than 1 and greater than 0. So this is fractions and decimals. Have a negative power of 10. Okay, so for example, 0.0000364. Step 1 is figure out where you're going to put the decimal. Now in this case, we're going to put the decimal between the 3 and the 6 because that gives us 3.64. which is between 1 and 10. If you put the decimal between the 6 and the 4, if you put the decimal here, which is wrong, you would have 36.4, and we don't want that. That's too big. So you want the decimal between the 3 and the 6, and then we're just going to count how many places we move that decimal. 1, 2, 3, 4, 5. So we moved it 5 places, and this is a tiny little decimal. So this is 3.64 times 10 to the negative 5. Okay. I'm going to pause for a second, and I'm going to erase this, but I need to think about what we're doing next. So hang on. Okay, I'm going to erase this. So to convert to standard notation, you're going to move the decimal the number of places that is the power of 10. So for example, if we have 4.287 times 10 to the 8, that means we're going to move this decimal 8 places. So this decimal, go like this. 1, 2, 3, 4, 5, 6, 7, 8. And then zeros go there. So we're going to have 4, 2, 8, 7, 0, 0, 0, 0, 0, and then you can put your commas in like that. Okay, and I'm going to erase this because we're going to do a negative one. 3.15 times 10 to the negative 6. Same thing, but we're going to move it 6 in the other direction. So we've got 3.15. We're going to go 1, 2, 3, 4, 5, 6. Put the decimal there, and these all get zeros. So we've got 0.000000315. Okay, one more thing I need to show you, and then we're done. I know this is long. I'm going to erase. If it says 52 thousandths, if it gives you words, okay, that means the 2, oops, thousandths. Sorry, 52 thousandths. That means the 2 is in the thousandths place. So we've got tenths, hundredths, thousandths. So 52 thousandths is this number, okay? And the decimal goes here, and you go boop, boop. So we get 5.2 times 10 to the negative 2. Okay? So you're going to do a column, and if you have trouble with it, I will help you in class. Thanks.